we discussed some types of limits, right? Can you remember what is the first type? Tell me, just a revision, right? Limit. Limit means what? We are analyze. We study. Let's say f of x is a function, right? F of x is a function, right? So let's say f of x is equal to x squared plus 2x plus 3 or something, right? Now we will find out what will happen if x approaches, if delta x, or if x approaches particular value, if x approaches particular value 3, what will happen for this function, right? Let's say limit x approaches 3, what will happen for this function, right? That is we can call, so it means if x approaches 3, what is the value f of x takes, right? That is we can call limits, right? So it means normally what will happen, so if it is a graph, right? So this is x, y-axis and x-axis, right? Then let's say this is the value 3, right? Now we need to analyze, we need to study what will happen from this side and this side. So we will find out the value for f of x for both sides. Then we are getting the sum of these two and divided by 2. So that is the value for f of x if x approaches 3. So if x approaches 3 means that is not x is equal to 3. Not take the value 3, right? It means x moving very close to 3, right? That is the meaning of that. So normally we need to do manually by creating a table to find out the limits, right? But it is a time consuming task, right? To avoid these things, we have some set of limit rules, right? So we discuss some 8 limit rules, right? So no need to do these things every time you create a table and analyze manually. If you find out limit x approaches to x approaches 0, right? If you have a function, c is a constant, right? So now f of x is a c. C means that is a constant, right? So in this is we can call constant function. So on that time, maybe let's say x take the value of a, then we can put that limit value for the constant is a c, right? Whatever the value, right? It means the graph is y is equal to c, right? Y is f of x is equal to c means this graph. F of x is equal to c means this graph. So always if we can use this value, right? It means limit x approaches 3, maybe 10 or maybe 5. So the answer is 5, right? The limit value for 5. This is first rule. Second rule we discuss, limit x approaches a, x is a function, right? Then what will happen? We need to replace with the value of a, right? So example, limit x approaches 5, limit x approaches 5, right? If you have a function x, so f of x is equal to x, in the sense we can put the value 5, the limit value for 5. It means if x approaches 5, the function f of x takes the value of 5, right? So that's the second thing. Third one, we discuss f of x plus or minus g of x, right? If you find out the limit for this, it is equal to, you can separately uh, get the limits, right? Limit x approaches a, f of x plus limit x approaches a, g of x. It is equal to this one. Similarly, limit, fourth one. So the fourth one, limit x approaches a, f of x into g of x. Then limit x approaches a, f of x multiple by limit x approaches a, g of x. Then what else? Fourth one. Then the fifth one. What is this? Fifth one, limit x approaches a, k into x. K is a constant. Then we can write k into limit x approaches a into x. So this way we can find out for fifth one. What about sixth one? Tell me. We discussed so many. What else? Anyone tell me one? If you remember. What is the next one? F of x over g of x. Limit x approaches a, f of x over g of x. Then separately you can put limit x up, limit x approaches a, f of x divided by limit x approaches a, g of x. Sixth one. So the seventh one, tell me seventh. What else? Hmm? Hello, are you in the session? So just I'm revising the thing, right? Already we discussed those things, right? So tell me, what else? Tell me, what else? Do you remember this one? X approaches a, f of x whole thing to the power of n. Then we can write limit x approaches a, f of x whole thing to the power of n. Similarly, we use with square root as well, right? So what is that? Yeah, very good. Someone tell the answer, right? Okay, the next one, limit x approaches a, f of x whole thing to the power of square root. Then we can put square root of limit x approaches a, f of a. Right? These are the 8 rules we discussed, right? So just revise the things. So go through the slides to understand those things, right? Last one, we discuss another rule, right? If it is a polynomial function, or if the function is a polynomial or rational function. Rational means f of x over g of x, not all the times, right? Most of the times, right? If you have a function f of x, so if you find out the limit x approaches a f of x, it is equal to f of a, right? So these are the things we are discussed, right? Then we discuss what? So different types of questions, right? We discuss some different types of questions, right? So what are they? First, you can direct substitution, right? So that is the first type we can discuss. So then we look at the questions, right? So first one is a direct substitution, right? So direct substitution. So at the time, if you get 0 divided by 0, that is undefined. So for that scenario, you cannot do the direct substitution. Then you need to apply the factorization techniques, right? Then you need to apply factorization technique. So you need to factorize the function. Then if possible, you can remove the common factors both side of the equation. Then you can continue directly apply the rules, right? So it means if you have a function f of x, you cannot find out the limits directly. Then you can find out another function g of x. It is equal to f of x. That is the meaning of factorizing, right? Then we discuss what? Factorization. If can't factorize, then conjugate. Conjugate form means square root of a plus square root of b means, let's say there is a function this way, we need to multiple both side of the equation by this conjugate of this square root of a minus square root of b. Likewise, the third type, right? Then what is the next one? Even if you can't, uh, okay, maybe you can apply with the conjugate forms, right? Factorization, conjugate, what else? What else? So the fourth one, right? If it is a complex functions, first you need to simplify the function, then you can apply the limits, right? So these are the different things we discussed yesterday, right? So I think you are revise the things and you are clear with those things, right? Those contents, right? Okay, now we will look at what is differentiation, right? So the term differentiation means, right? Yeah, differentiation means I already explained, right, yesterday, right? Just imagine, right? You have a square, right? You have a square, right? They have a is the length of one side, right? Now, right? This square has an area a is equal to a squared, right? So now what will happen if you do a small change? in one side of your square, depending on the change, your area will be changed. Do you agree with me? Normally that is true, right? Let's say I'm creating a square with one side length is A. Okay, just imagine, right? I am putting here as a 10 centimeter, right? Now, what will happen? The area is 100 centimeter squares, right? Now, what will happen? If I increase this length of this square by 1 centimeter, right? Now, I can increase the length by 1 centimeter. Because of that 1 centimeter, what will happen? My area will be changed, right? Now just think about, right? I can increase the length by 10 centimeter, right? Okay, now I can increase the length by 10 centimeter, right? Just imagine this is 10 centimeter, okay? This is 10 centimeter for length of one side. Now, the previous area is A1. A1 is 100 centimeter square. Now tell me, how about the square of A2? A2 means the red, one side of the length is 10 centimeter. Sorry, now the length increased by 10 centimeter. So the now new length is 20 centimeter, right? Now tell me, if the length is 20 centimeter, so 20 centimeter into 20 centimeter, how many? A2 equal to 400 centimeter square, right? So depending on the change I am doing in the side length of one side, my area is changing, right? So it means depending on the change I am making on a one variable, another variable. So this is the function, right? A is equal to A into A. Just imagine this is X, right? A is equal to X into X. X is a length of a one page, one side, right? So A is equal to X squared is a function. Here, X is called independent variable. Independent variable. A is the dependent variable, right? So now what will happen? The change we are doing on the independent variable X, depending on the change of X, independent variable also change, right? Do you agree with me? If you do a small change on one variable, because of that one variable change, your dependent variable area also will be changed, right? Okay, so differentiation means we are analyzing these changes between the variables, right? So we need to create a function, right? First, we need to create a function. Functions means what? The connections, the relations between the variables we can call as a functions, right? Now, uh, we need to analyze the differences between the variable we can call as a functions, right? So now just think about, okay, now I am moving by 1 centimeter, right? Now what will happen? Area A3 is equal to, now this area is equal to what? 11 centimeter into 11 centimeter, then 121 centimeter square, right? Depending on the change of my independent variable x, length of a one side, my area, the dependent variable area also will be changed, right? Now we are in the differentiation, we are planning to discuss the changes of variables, right? So here, now first we will look at average rate of change, right? So this changes, even if it is a square, it is a stable changes in the variable, right? Just imagine, right? A vehicle is moving, right? One vehicle is moving, right? So now what will happen? That vehicle cannot move the same velocity always, right? Because we have roads, right? So they have different barriers, different uh, fractions or different obstacles, right? So maybe we cannot drive a car with the stable speed from point A to B, right? Definitely because of different fractions or different obstacle, your speed will increase, decrease, right? So if you don't have a stable changes in your particular relations, what will happen? You need to find out the average rate of change. We cannot say the fixed stable changes happen frequently, right? So if I ask you, let's say there are 2 points A and B, right? From A, Oliville, Southeastern University to Ampara, right? So I need to travel. Now I am asking you, what is the velocity of your uh, this journey, right? We cannot say from beginning of Oliville until Ampara, we use the same speed. It's not possible, right? It's a not a uh, realistic things, right? It is ideal. You are traveling this way. So to find out the velocity means your velocity will change on different points, right? Maybe some certain this in you have a particular velocity v1. From here to here, you have another velocity v2 until here v3. Likewise, your velocity will be changed for different frames, right? So if the total change, total velocity, the overall journey velocity means that is the average velocity. The meaning of this means someone asking you what is the average velocity, right? So if you find out this average velocity, that is we can call rate of change, right? That is the differentiation as well. That is we can call as a differentiation, right? So now first look at what is average rate of change. Just imagine, right? You have a function y, let's say maybe a function x squared plus 2x plus 3 or something, right? You have a function you have a function y on a variable x. So x is an independent variable, y is the dependent variable. Y is depending on the value of x. Let's say this is a function, right? Function means maybe for some purposes you are creating a function, right? It means you are find out the relation between variables. So this is the relations between the variable, right? Let's say if you create a equation for volume, right? That's the relations between the length, width, and height of that shape, right? Likewise, this equation f of x is a function. Some reasons they are generating a function between the relation of x and y. So this is something a function. Function means they will find out a relation between the variables, right? So this is a function. Okay. Now, so we can write this one as a y is equal to f of x. Both ways you can write, right? So now just think about, right? If I now just think about if I do a small change, right? Small increment or small decrement. If I do a just imagine increment only, okay? Just think about if I increase the value, right? By default, x have some value, right? Just think about x have a value, right? If I increase the value of x by small value. Let's say now just think about x is a 10 centimeter, right? Now I increase the value of x by 0 point, right? Now I increase the value of x by 0.001 centimeter, right? So this small distance, we can say as a delta x, right? So if you increase a very small value, that small value we can call delta x. Delta x means derivatives. We can call in another term derivatives. Derivatives means the small changes you are doing for a variable, right? This is your equation y is equal to 2x plus 2x squared plus 2x plus 3. Then if you do a small increment, a very low minimum increment, there's a very micro level increment, small, very small increment for your x. Now what will happen? Your x is equal to, right? let's say you have your x value previously maybe x node or something, right? Now what will happen if you increase the value of x by small distance? Let's say this distance we can say x delta x, right? Now your new x value becomes delta x naught plus delta x, right? So because of this x value, definitely what will happen in your y value also will change, right? So now what will happen, right? If you increase the value x, if you increase the value x by delta x, right? So this is your beginning level x, right? At that time, you have the y value, right? Let's say if you think about the previous example, a is equal to x square. If you have a square, a is equal to x square, right? Now what will happen? If you, this is a base value, right? X and x, right? Now if you do a small increment for your x, right? Now you are doing a small increment. Delta x is a small increment for your one side of your square. Depending on that small increment, your y value also, y value means your area also will change, right? So your y value will change by a delta x, delta y, right? So this delta x means the small changes, small increment you are doing for your independent variable. Because of that increment, your dependent variable y also increase by delta y, right? Just think about, if you increase the length by 1 centimeter, right? Definitely in your area, there will be an increment, right? Did you get my point? If you increase by delta x, right? If you look at the previous example, if let's say delta x is equal to 1 centimeter, just imagine delta x is equal to 1 centimeter, right? So previously your x is equal to 10 centimeter, right? Now if you increase your delta x by 1 centimeter, now what will happen? If it is a x means your area is equal to 100, right? Now what will happen? If you increase your x by delta x, so now what will happen? New x is equal to 10 plus 1. So that is 11 centimeter. Because of that, you have a increment on your y, right? That is we can call delta y. So delta y means the increment on your area, right? How you can find out the increment on your area? So you need to find out this colored area, right? If you find out this colored area, that is the increment. So that increment will be how many? 21 centimeter squares, right? So what will happen if you increase one independent variable? Because of that increment on your independent variable, your dependent variable also will change, right? So if we find out this change rate, that is we can call as a differentiation, right? So so you have a function. On that function, functions means the relation between the variable, right? So you have a variable, two variables, x and y. So you can find out a relation between two, not only two, right? Maybe more than that two variables also possible, right? So functions mean the relation between the variable, right? Now, what will happen if you have a function, one is a dependent variable, another one is an independent variable, right? If you do a small change on your independent variable, because of that change, your dependent variable also have some increment or some changes, right? So if you find out the uh, difference between the changes of x, delta y over delta x, that is called differentiation, right? So you have a x on that time, you have the y is the value, right? So now if you increase x plus delta x, if you increase the value for x by delta x, because of that in your y variable, in your independent variable, in your dependent variable also have a small increment, right? So let's say this is the initial stage, you have the value x. On that time your function have the value y, right? So if you do a increase, do you have a x value, x length of your one side, you have an area that is y. Now, if you are doing a small change with your x, if you do a small change in your independent variable, because of that change on your independent variable x, your dependent variable y also have a small change, right? Now, if you find out the changes between delta x over delta y, this is called differentiation, right? So if you find out delta x over delta y, that is we can call differentiation, right? Or sometimes we can write this one as a this delta, right? This is also delta, right? So delta, they have this symbol, uh, lowercase, simple delta. This is uppercase delta, right? So maybe this is also we can call delta, right? This is also called delta. Sometimes they will tell, right? Uh, delta x this way, delta y this way, right? So delta x over delta y or delta x over delta y, both are same meaning, right? So if you find out this one or this one, both are same, no? So this is we can call differentiation, right? So what they are telling here, right? Yeah, y be a function of x. So let's say y is equal to f of x. Suppose delta x. So here they are using this delta x, right? This is equal to this is delta x. Both are same, right? Maybe you can use whatever, right? Both are same. So suppose delta x represent a small change in the value of x, right? Delta x means you are doing a small change. So in this example, this 1 centimeter is the small change, right? So that is delta x. If you increase 1 centimeter increase, delta x is a small change in your value x from x naught to x naught plus delta x. So from 10 to 11, in the initial stage 10 centimeter, then your increase by 1 centimeter means 10 centimeter to 11 centimeter, right? From x naught to x naught plus delta x. At that time, suppose delta y means that is the increment, that is the corresponding change of value y, right? If you do a small increment on x variable, because of that small increment, your y variable also have a small change, right? That change on y variable y, we can say as a delta y. So if you increase by delta x, because of that, the increment of variable y is delta y, right? So for the corresponding delta x, we have a delta y is the corresponding change of value in the delta y. Change means maybe increment or decrement, right? So if it's the area, definitely it will increase, right? Maybe some different relation, different function here, maybe they will decrease, right? It's up to the functions for which they are created, right? So now, how we can find out? Just look at here. So you have a function f of x, right? So f of x is equal to something, right? Maybe x squared plus 2x plus 5 or something, right? Now, so if I increase delta x on x, if I increase delta x, so now what will happen? Because of the increment of delta x, if I increase the value, small value of x by delta x, because of that, there is an increment on my variable y, that is we can call as a delta y, right? Now I already told you the average rate of change means delta x over delta y, right? So that is equal to what? So how you can find out? Sorry, I write this way, right? Delta y over delta x, right? It means if I do a small increment, x related, right? By x related, if I do a small increment on x, because of that small increment on x, my y value, my function f of x also have a increment, right? So that change delta y over delta x, we can call that is the average rate of change. How we can find out this delta y? Hmm? How we can find out this delta y? Tell me. So now we need delta y over delta x, right? How we can find out delta x, right? Now previously we have x naught, right? X naught is the base length of x, base value of x. Now what is the value of f of x naught? Tell me. So f of x naught is what? X naught to the power 2 plus 2x naught plus 5. Did you get my point? Now what will happen? X is equal to x naught. Now I can do a small increment for x naught plus delta x. Now I can increase the value from x naught to x naught plus delta x. Now f of x naught plus delta x is equal to x naught plus delta x whole thing to the power of 2 plus 2x naught plus delta x plus 5, right? Sorry, plus 5, right? So now this is my f of x naught plus delta x. So this is my new y, right? This is my earlier y, right? Now, so delta x means what? Tell me. Delta x, sorry, delta y means what? Delta y over delta x, right? So now tell me, delta y means what? F of x naught plus delta x minus f of x naught. So if you look at the previous example, right? So if you look at the square example, right? In the initial stage, we have a square with 10 centimeter. Now, if I increase by, sorry, if I increase by 1 centimeter, so 1 centimeter. Now, how I can find out? So a is equal to x squared, right? So now a naught. So a naught is equal to 100 centimeter squared. So a1 is equal to 121 centimeter squared. So a1 minus a naught, right? That is f x plus delta x minus f of x naught means what, right? So new area minus the earlier area, right? So a1 minus a2, that is the thing. F of x naught plus delta x minus f of x. So that is the meaning of this delta y over delta x. Delta x means that is the delta x means here 1 centimeter is the delta x. We are increased by small value. If you increase the uh, value of x by 1 centimeter, because of that, the change happen on the variable y, this one, right? This is we can call average rate of change. If you do a small change, if you do a small value change on x, if you do a small value change by delta x on your variable x, because of that, the value change on your variable y, the delta y, f of x naught plus delta x minus f of naught. That is the way we can find out the rate of change, right? So rate of changes means nothing. If you do a small increment or decrement on your variable x, because of that change on your variable, your y value also will change, right? If you increase the length of the one side of your square, because of that, definitely your area of the square will be changed, right? So that rate of change means we can divide the delta A. Delta A means the area changes divided by delta X. So if you increase the length of one side of the square, it will influence by the this delta A, right? Now we will look at one example, then you can easily understand what is rate of change. Okay, just look at this example. Just imagine you're running a company, right? Just imagine, right? You are running a company. Okay. You are running a company. Okay. You are running a company, right? You are manufacturing something, right? Let's say you are manufacturing, yeah, you are manufacturing a particular, okay, just think about you are manufacturing chairs, right? You are manufacturing, okay, you are manufacturing some type of chairs, right? Just think about you are manufacturing a chair, right? Now they are giving, suppose that the cost of production X, suppose that you are manufacturing some chairs, the product producing X units of a certain item. So you are manufacturing X units of chair is given by C, right? So the cost means what is the cost you need to invest to manufacturing n number of chairs, right? So they are giving a function C of X. C of X means 10x plus 20 over X, right? So X always greater than 0. It means if you are manufacturing something that cannot be a negative number, right? So what is the meaning of this function, right? The meaning of this function, depending on the cost and the number of chairs you are manufacturing, you have an equation, right? Equation means what about the cost will varying, cost will changing with number of chairs you are manufacturing, right? It means, let's say you are manufacturing more number of chairs, maybe your manufacturing cost will be reduced, right? Rather than if you are manufacturing 10 chairs, if you manufacture 100 chairs, maybe the cost will be reduced. Maybe different factors influence, right? Just think about if you manufacture 10 chairs on a one day, you need to pay for the workers for one day, right? Even for that day, you can have capable of manufacturing 100 chairs, right? Just think about 10 employees are working on a in your company, right? For each employee, you are giving 1,000 rupees per day. So if you hire 10 employees for one day for manufacture 10 chairs, what will happen? You need to pay 10,000, right? So 10,000. So for one chair, your labor cost is 10,000 divided by 10,000 rupees for labor cost coming for one chair manufacturing, right? So similarly, just think about you have only 10 employees, uh, daily salary for them 1,000 rupees, but on that day, you are manufacture 20 chairs, right? If you manufacture 20 chairs, so at that time, labor cost is how much? So the labor cost is 10,000 divided by 20 chairs. Now for one chair, the labor cost is 500 rupees, right? So previously 1,000 rupees labor cost for one chair. Now the labor cost is 500 rupees, right? Now what will happen? Labor cost will be reduced half, right? So they have some meaningful thing, right? If you manufacture more things, the cost of the labor cost or something, the cost of manufacturing will be reduced. This is one real example I am telling you, right? So that is the factory is working, right? Rather than we are manufacturing few numbers, if you are manufacturing more numbers, they have more benefits, right? It means their cost of the manufacturing will be reduced, right? So this is a one company, they are manufacturing chairs, right? So depending on number of chairs they are manufacturing, so X means how many chairs they are manufacture on a day. Depending on the number of chairs they are manufacture, the manufacturing cost will be given by this equation, right? Now previously f of X is equal to we are giving, now they are giving similarly C of X is equal to 10x plus 220 over X, right? Now tell me, well, how about the cost for manufacturing one chair? So now I am asking you, what is the cost for manufacturing one chair? So what is the cost for manufacturing one chair? So how you can find out? So in the question, they are clearly mentioned, right? Cost of product producing or production, cost of production, X units means X chairs. X unit means X chairs is of a certain chairs given by this equation 10x plus 20 over X. So if you replace the value for X, X means the manufacture number of how many units you are manufacture, depending on the number of units you are manufacturing, what will happen? Your manufacturing cost will be change, varying, right? Now tell me, what is the cost for manufacturing one chair? How to find out? Tell me the answer. What is that? What is the cost for manufacturing one chair? Tell me. What is the cost for manufacturing one chair? Just a simple replacement. What did you do? I'm already giving an equation, right? So if I manufacture X chairs, so this is the cost. 10x plus 20 over X is the cost for manufacturing X number of chairs. Now I am asking, what is the cost for manufacturing one chair? Tell me the answer first. Tell me the answer first. Any volunteer? Tell me the answer. Anyone? Yeah, just think about, right? The previous example, just think about the area is equal to, okay, just think about this way, right? So area is equal to in X, right? The square of area is given by X square, right? Now what will happen if the X is equal to 10 centimeter, A10 is equal to what? 100 centimeter squares, right? Now if I increase X is equal to 10 plus 1 centimeter. Now if the X is 11 centimeter, now what will happen? A11 is equal to uh, 10 11 to the power 2, right? Here what will happen? Here 10 to the power 2, so 100. Here 11 to the power 2, 121. This is what we are discussed. Similarly here I'm giving an equation, right? So what is the answer for this? Don't you understand what I'm saying here? Hello. So what is the cost for manufacturing cost for one chair? Tell me. What is the production cost for one chair? What is the cost? What is the cost for one chair manufacturing? What is the cost for manufacturing one chair? Tell me. Hello. Am I audible? Any volunteer? Tell me the answer, right? If you understand, if you don't understand, I will explain, right? So, what about others? Done at the. So just think about this example, right? We know the function. Functions means what? Functions means the relations. Functions means the relations between the variables, right? Let's say f of x is a functions means that is a function with the independent variable x, right? Let's say x cube minus 3 or something, right? It means if we, uh, okay, these are functions mean the relation between the variable x, right? Let's say, uh, okay, just think about, uh, okay, this is a manufacturing cost of making a laptop, right? So if you are making a laptop, right, this is a manufacturing cost. It means, okay, so it means depending on the number of laptops manufactured, the cost will be change, right? So this is a function means, right? Here they are giving a function c of x, 10x plus 20 over x means, right? If you manufacture one chair, the cost will be, you need to replace for x by 1, right? That is a, so functions mean the relations between the variable, right? Yeah, yeah. You are asking why we are using 20 over x. So it is not 20 over x. It's not for, we don't know the meaning, right? So a company, they have some formulas, right? That is the relation they will find out, right? We don't know why they are putting 20 over x. So functions means, right? Just imagine a of x means x squared. Here we know why we are putting x squared. So area of x is a function, right? So square. So if you have a square, right? The area of this square means this is x, this is y, right? Then we know to find out the area, you need to get the multiplication of x twice, right? That's why we are creating this equation, right? Similarly, for this equation, they have some meaning, but we don't know that meaning, right? Definitely they have some meaning, right? So we don't know why they are putting 20 over x. So here we know, because the square means we need to get the multiplication of length and width, right? Square means especially one side length, you get the square value, that is the area, right? These relations we know. Similarly, definitely each functions have some relations, right? So even these functions also, these functions, yeah, these functions definitely have some meaning. So that we don't need to think why they are putting 20 over x, right? That is their company model, right? We don't know why they are putting that trait. So they are just giving, this is a function, right? This is the function, how the number of units they are manufacturing influenced by the cost. So now, if in this function, to find out the cost for one chair, just nothing, right? Just you can put x is equal to 1. So x is equal to 1 means, in the function, x is equal to 1 means the cost they need to manufacture for one chair, right? So C of 1 means the cost of manufacturing one chair, right? So 10 multiple, for x you need to replace by 1, 20 over 1, right? So 10 plus 20, 30 rupees for manufacturing cost for one, right? Now just think about what is the manufacturing cost if I manufacture two chairs, right? Just nothing, you can replace by 2. So x is the relation between the number of units you are manufacturing, right? X is indicated by, x is the variable number of cost you are manufactured, right? Now the manufacturing cost for one chair, 10 to 30 rupees. Now if I put cost for two chairs, so just I can replace x is equal to 2. So C of 2 is equal to 10 into 2 plus 20 over 2. Right now what happened? 20 plus 10, 20 divided by 2, 10. Right now if you notice here, 30 rupees. Just think about, even if you may manufacture one chair, you are getting the same cost. Even if you get manufacture two chairs, you are getting the same cost, right? So just think about for three chairs. Give me a minute. Okay, just find out what is the cost for three chairs. Okay, what is the cost for three chairs? To manufacture three chairs, what is the cost? C of 3. So 10 into 3 plus 20 divided by 3. So 30 plus maybe 6.67, right? So 36.67 rupees, right? So that's why already I given real example, right? If you increase more items, definitely the manufacturing cost will be reduced, right? So this is a relation, right? So this is their company model. Maybe this relation, right? They are multiplied by 10 divided by 20. It is depending on their salary they are giving for their employees, how many working hours. They influenced by different factors. We don't know why they are putting 20 over x. Just they are giving a function. That function means the relation between the two variables, right? So here, what are the variable? Number of uh, objects, number of chairs you are manufacture, that have a relation with the manufacturing cost. So this function explains what? This function explains the relation between the manufacturing cost and the number of units they are manufacture, right? Depending on the number of units they are manufacture, the manufacturing cost will be changed. That is the relation within the function, right? So now they are giving a question, right? Uh, X units, yeah, they are giving the function. Then the average rate of change C is respect to X as changes from 4 to 5. So now they are asking, right? Okay, now they are asking, right? What is the average rate of change? Average rate of change, average rate of change, the manufacturing 4 units and 5 units, 4 units to 5 units, right? So they are asking what is the average rate of change. So it means what is the change happen in the manufacturing cost if they manufacture 4 chairs and 5 chairs, right? So how to do that? So now they are asking, right? If you look at here, what is the average change between 1 chair and 2 chair? 0, right? 0 is the change between 1 chair and 2 chair. What is the average rate of change? 2 chairs and 3 chairs. If you manufacture 2 chairs, what is the cost you need to find out? Similarly, you need to find out what is the uh, manufacturing cost if you manufacture 3 chairs, right? So that is the difference between C of 3 minus C of 2. That is, we can call average rate of change in the cost if you manufacture 3 chairs and 2 chairs, right? So the C3 is 36.67 minus 30. So the average cost of average rate of change in the cost 6.67 rupees, right? Similarly, in this question, they are asking what is the average rate of change if you manufacture 4 chairs to 5 chairs, right? It means first you need to find out what is the average cost. What is the cost for manufacturing 4 chairs? Cost for 4 chairs, just you can replace x is equal to 4. X is, if you replace x is equal to 4 means that is the relation between number of chairs you are manufacture and the cost of the manufacturing, right? So that is the relation. So if I put x is equal to 4, C of 4 means that is the cost of 4 chairs manufacturing, 10 into 4 plus 20 over 4. So the cost C4 is equal to 40 plus 5, 45 rupees. 45 rupees is the manufacturing cost for 4 chairs manufacture. Similarly, if I put x is equal to 5 means that is the cost of manufacturing 5 chairs, right? So 10 into 5 plus 20 divided by 5, then 50 plus 4, so 54 rupees. Now they are asking the average rate of change between 4 chairs and 5 chairs. So how you can find out? So just, so it means they are asking what? So now they are asking average rate of change means, okay, I already told you, if you have a function f of x, right? Maybe they are something. So average rate of change mean delta y. Let's say y is equal to x squared minus 3x or something. Delta y over delta x is the average rate of change, right? Now what we need to do, average rate of change means we need to find out delta c over delta x, right? So delta c means what? Delta phi, delta c means C5. Delta phi means, so the cost change, average cost change, manufacturing cost change means, first we need to find out what is the cost for manufacturing 5 chairs minus what is the cost for manufacturing 4 chairs, right? So that is delta C over delta X means number of X units. So how many X units? 5 units minus 4 units, right? Now 54 del, C of 5, 54 minus 45 divided by 1. So that is equal to 9 over 1. 9 rupees is the total average cost change, right? So that is the average change. That there is nothing. You don't need to worry about differentiation or something. It's a basic mathematics, right? If you have a function, we know functions is a relations between the variable, right? So in these functions, you have a variable is x, right? X means number of units you are manufacturer, right? So depending on the number of units you are manufacturing, your manufacturing cost will be changed, right? That's the relation. Depending on the value of x, you are getting different costs, right? So that is a function. Now what we need to do, they will ask you what is the average rate of change between manufacturing 5 chairs and 4 chairs. Okay, now tell me, right? Similarly, I'm asking you a question, right? Now tell me what is the average cost range uh, between okay 10 chairs to 11 chairs, right? So what did you do? The average rate of change means first you need to find out what is the cost for manufacturing for 11 chairs. So C of 11. So C of 11 is equal to 10 into 11 plus 20 over 11, right? So maybe 110 plus 1.8 something, right? Okay, now similarly, we need to find out the manufacturing cost for 10 chairs. So 10 into 10 plus 20 over 10, right? Then 100 plus 2, 102. Here, 110, maybe 111.8. So the manufacturing cost change means C11 minus C10, 111.8 minus 110 divided by 11 chairs minus 10 chairs, 1 chair, right? 11 minus 10. So the value is 9.8 over 1, right? That is the average rate of change, right? So average rate of change means you need to find out the value on a particular value, right? Similarly, just think about A is equal to X squared, right? Okay, then you can easily understand, right? Just think about, wait. Okay, I will explain with this example, then you can easily understand. Just imagine this air, this, uh, okay, I think you know what is function, right? Okay, now I am telling you a function A of x, right, is equal to x squared, right? So this is a function between the area of a square, right? This is a function between the area of square, right? So now we need to find out what is average rate of change. Don't think about too much of differentiation. We don't move for differentiation up to now, right? Just we are find out what is the average rate of change, right? Now I'm giving you a function a of x is equal to x square, right? It means the relation between the variable x and the area, the functions between the x and area. So it means if you increase the or decrease, if you increase or decrease the length of one side of a square, depending on the increase or decrease, your area will be changed. Do you agree with me? So if you increase the, let's say, if you increase this, let's say this is x, right? If you increase this x, depending on the increase of x, your area will be changed, right? If you increase by 1 unit, definitely your area also will be increased by 1 unit, not 1 unit, right? We don't know. That's the thing, important thing, right? If you increase the area by 1 unit, x is equal to x plus 1, we don't know how about the increment of area. Definitely area will not increase by 1 unit, right? We cannot say area also increase by 1 unit, right? So depending on the relation between your variables x, they have different increments, right? Now the rate of change means, let's say, just imagine they are giving you a function, right? So the length of one side influenced by the area, right? Now they are telling you, right? Someone create someone create a square with 10 centimeter. Someone create a square with 10 centimeter, right? Another person create a square with 11 centimeter, right? Another person create a square with 11 centimeter, right? One guy create a square with 10 centimeter. So 10 centimeter means he get a specific area, right? Another guy create another square with 11 centimeter, right? So if you find out the difference between these two, that is the average rate of change, right? So how you can find out this average rate of change? First of all, we need to find out what is the, so it means depending on this, let's say if you have a 10 centimeter, if someone increase by 1 centimeter by his length, because of that length increment, his area will be increased, right? So now we are considering only the increment of that area, right? That is average rate of change. So if you look at here, so maybe if I inside this, like let's say, so this area will be the, this area will be the increment, right? So if you find out this area, that is the average rate of change, right? Now, what I'm doing here, I'm trying to find out this average, this area, this red colored area, that is the rate of change. That is the change happen, right? So how you can find out? First of all, you are replaced with x is equal to 11 centimeter, right? If you put x is equal to 11, what will happen? A11 is equal to, that is your area after increase by 1 centimeter. So what is the area now? A11 is equal to 11 to the power 2. 11 to the power 2, 121, right? Units, maybe whatever the units, right? 121 is the A11. Now, rate of change means what? I need to get the differences of new value minus earlier value, right? Now, the previous value, x is equal to 10. Now, A10 is equal to what? 10 to the power 2, 100 centimeters squared or 100 units, right? Now, if I need to find out the average rate of change is equal to A11 minus A10 over rate of change means this area change happen by with change in my x, right? The change of x means x11 minus x10. So x11 means my length is 11 centimeter. New length is 11 centimeter minus previous length is 10 centimeter, right? So that's a change. So now A11 is 121, 121 minus 100 divided by 11 centimeter new one length of one side, 10 centimeter new length of one side. So 11 minus 10, 1. So it is equal to 21 centimeter square. This is the average rate of change in this function, right? So whatever the function, we can find out the rate of change means you need to find out the differences between a particular point. That is we can call average rate of change, right?